Hello students, let us discuss few questions and their solutions from the chapters Triangles and Application of Trigonometry from grade 10. Question number 1. If 300-meter high pole makes an angle of elevation at a point on ground which is 300 meter away from its foot, then the angle of elevation is. Options given are A 60 degree, B 90 degree, C 30 degree, D 45 degree. Solution. Here given that height of the pole is equal to distance is equal to 300 meter. So tan theta is equal to 300 by 300 which is equal to 1, which implies theta is equal to 45 degree. So the right option here is D 45 degree. Question number 2. The angle of depression of a bike parked on the road from the top of a 90-meter high building is 60 degree. The distance of the bike from the pole is. Options given are A 20 root 3 meter, B 90 meter, C 15 root 3 meter and D 30 root 3 meter. Solution. Here tan 60 degree is equal to 90 by D. Upon solving we will get D is equal to 30 root 3 meter. So the right option is D 30 root 3 meter. Question number 3. The top of two poles of heights 20 meter and 14 meter are connected by a wire. If the wire makes an angle of 30 degree with the horizontal, then the length of the wire is. Options given are A 8 meter, B 10 meter, C 12 meter, D 14 meter. Solution. Here given that the wire makes an angle B is equal to 30 degree. The first pole BE is equal to 14 meter and the second pole which is AD is equal to 20 meter. Now the difference of both the poles which is 20 minus 14 is equal to 6 meter, which forms the vertical. So here we are using the trigonometric ratio. In triangle ABC, sin B is equal to AC by AB. Sin 30 degree is equal to 6 by H. Upon solving, we will get 1 by 2 is equal to 6 by H, so H is equal to 12. So the right option here is C 12 meter. Question number 4. If triangle ABC is similar to triangle EDF and triangle ABC is not similar to triangle DEF, then which of the following is not true? Options given are A. BC into EF is equal to AC into FD, B. AB into EF is equal to AC into DE, C. BC into DE is equal to AB into EF, and D. BC into DE is equal to AB into FD. Now solution. Since triangle ABC is similar to triangle EDF, the proportional sides are AB by ED is equal to BC by DF is equal to AC by EF, which gives us AB into DF is equal to ED into BC, or AB into EF is equal to AC into ED, or BC into EF is equal to DF into ED. So it is very clear that BC into DE is not equal to AB into EF. So the right option is BC into DE is equal to AB into EF. Question number 5. In the given figure, value of X is. Options are A 4 cm, B 5 cm, C 6 cm, D 8 cm. Solution. Here triangle PAB is similar to triangle PQR. We know that corresponding sides of similar triangles are proportional. So we have PA by PQ is equal to AB by QR, which implies 2.4 by 6 is equal to 2 by X. Therefore, the value of X is equal to 5. So the right option is B 5 cm. Question number 6. In the given figure, angle T and angle B are right angles. If the lengths of AT, BC and AS in centimeter are 15, 16 and 17 respectively, then the length of TC in centimeter is. Options given are A 18, B 16, C 19 and D 12. Solution. By using Pythagoras theorem, we will get the length of TS is equal to square root of 289 minus 225, which is root 64. Therefore, the length of TS is equal to 8 cm. Now, taking triangles ATS and triangle ABC, we have angle ATS is equal to angle ABC, both are 90 degrees. Angle TAS is equal to angle BAC is common. So, triangle ATS is similar to triangle ABC by AA similarity. Then we have AS by AC is equal to TS by BC. So, AS into AT plus TC is equal to TS by BC, which implies 17 into 15 plus TC is equal to 8 by 16. So, solving we will get TC is equal to 19 centimeters. So, the right option is 19 centimeter. Question number 7. In the given figure, AD by DB equal to AE by EC and angle ADE is equal to 70 degree. Angle BS is equal to 50 degree, then angle BCA equal to. Options given are A 70 degree, B 50 degree, C 80 degree, D 60 degree. Solution. Since AD by DB equal to AE by EC, by basic proportionality theorem, we have DE is parallel to BC. So, angle ABC is equal to 70 degree, which is corresponding angle to angle ADE. Angle BS is equal to 50 degree is a given data. Now, in triangle ABC, angle ABC plus angle BAC plus angle BCA is equal to 180 degree, which implies 70 degree plus 50 degree plus angle BCA is equal to 180 degree. Therefore, the measure of angle BCA is equal to 60 degree. Right option here is D 60 degree. Question number 8. Assertion. The ladder 20 meter long makes an angle 60 degree with the wall. Then the height of the point where the ladder touches the wall is 15 meter. Reason. For an angle theta, cos theta is equal to adjacent side by hypotenuse. Solution. AC is the ladder and we have to find BC in the given picture. From the figure, it is clear that cos 60 degree is equal to BC by AC. That is 1 by 2 is equal to BC by 20. So the length BC is equal to 10 meter. Therefore, our assertion will be wrong. So the right option is D. Assertion is false and reason is true. Question number 9. A pole casts a shadow of length 2 root 3 meter on ground when the sun's elevation is 60 degree. Find the height of the pole. Solution. Let AB be the pole and BC be the shadow. Taking triangle ABC, we have tan 60 degree is equal to AB by BC, which implies root 3 is equal to AB by 2 root 3, which implies AB is equal to 6 meter. Hence, the height of the pole is 6 meter. Question number 10. In triangle ABC, D and E are points on the sides AB and AC respectively, such that DE is parallel to BC. If AD is equal to x, DB equal to x minus 2, AE is equal to x plus 2, and EC is equal to x minus 1, find the value of x. Solution. From the diagram, the ratios AD by DB is equal to the ratio AE by EC by basic proportionality theorem. Upon solving the ratio, we will get the value of x is equal to 4. Section C contains one question carrying 3 marks. Question number 11. If a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then prove that the other two sides are divided in the same ratio. Here given that in triangle ABC, DE is parallel to BC and AB and AC are intersected by DE at points D and E respectively. We have to prove that AD by DB equal to AE by EC. Construction. Join BE and CD. Draw EG perpendicular to AB and DF perpendicular to AC. Now the proof. We know that area of triangle ADE is equal to half into AD into EG. Area of triangle DBE is equal to half into DB into EG. Area of triangle ADE divided by area of triangle DBE is equal to AD by DB. Let us consider this as equation number 1. Similarly, we have area of triangle ADE by area of triangle ECD is equal to AE by EC. Let us take this as equation number 2. Now, we know that triangle DBE and triangle ECD are the same base DE and also between the same parallels, that is DE and BC. Therefore, we will get area of triangle DBE is equal to area of triangle ECD, which is equation number 3. Comparing equations 1, 2, 3, we get AD by DB equal to AE by EC. Hence, we have proved the theorem. Section D contains one question carrying 5 marks. Question number 12. A man rowing a boat away from a lighthouse 150 meter high takes 2 minutes to change the angle of elevation of the top of lighthouse from 45 degree to 30 degree. Find the speed of the boat. Use root 3 is equal to 1.732. Solution. Let AB be the lighthouse. AB is equal to 150 meter. Initially, boat is at C and after 2 minutes it reaches at D. In right angle triangle ABC, AB by BC is equal to tan 45, which implies 150 by BC is equal to 1. Therefore, BC is equal to 150 meter. In right angle triangle ABD, we have AB by BD is equal to tan 30. So, 150 by BD is equal to 1 by root 3, which implies BD is equal to 150 root 3. Distance covered in 2 minutes is equal to BD minus BC, that is 150 root 3 minus 150, which is equal to 150 into root 3 minus 1 meter. We have speed is equal to distance by time, that is 150 root 3 minus 1 divided by 2, which is equal to 150 into 0.366 is equal to 54.9 meter per minute. Thank you children. Thank you for watching.